In this problem, we're told that if x represents an even number, what expression represents an odd number? So even and odd numbers, if we just look at the counting numbers, for example, just to get a sense of how this works. With even and odd numbers, there's just this alternation between them. So if we start at 1, right, and then start at an odd, and then go to an even, and then go to an odd, and then go to an even, this always happens, this alternation between odds and evens, odds, right, and evens, and so forth. So we know that every time we add 1 to an odd, we get an even. And reverse, if we add 1 to an even, or subtract 1 to an even, we go to an odd, right? So add 1 to 2, we get 3, that's odd. Take 1 away from 2, we get 1. That's also odd. Add 2 to 2, and we stay even. Add 3 to 2, and we go back to odd. So this brings up another connection that if we take an even number, and we add an odd or subtract, let me write that like this, take an even, if you add or you subtract an odd amount, like 1, you're going to get an odd number. If you take an even number and you add or subtract an even amount to it, you get an even number, just like 2 plus 2 is 4. But if you take an odd plus or minus an odd, right, what do you get? Well, in that case, right, you still get, well, let's try it. If we have 1 and we add 3, we get 4. If we add 3 and 5, 2 odds, we get 8, which is also even. So add or subtract 2 odds and we get an even. So that helps us a little bit because we know we're starting with an even number. If in choice C we add 3 to it, we're guaranteed to get, right, an even plus an odd, another odd value. So that takes us from even to odd. But let's look at the other ones to see if we can find counterexamples. Because if you're confused by this, you can always plug in values to see what's happening. So when you plug in values, here just remember that x is even. So if we try A, if I take x equals 6, then what happens? Well, then we have 6 divided by 3, and that's 2. So we started with an even, and our result was even. So A doesn't work. We're trying to get an odd number. In B, if x equals 6 again, then 3 times 6 gives us 18. Wow, okay, that's still even. And that makes sense because this means 3 groups of 6, or 6 plus 6 plus 6, which is really an even plus an even plus an even. And what did we say? Well, we said an even plus an even is even. And now D says x to the third. Well, I'll try 2, right, is even. 2 to the third, so x is equal to 2. What happens? Well, this just means 2 times 2 times 2, which is 8. And that makes sense because all we're doing with exponents is we're repeating multiplication. So we're taking groups and groups of even numbers because our base, our x value, is always even. So we're always stuck with an even result. So D is out as well. So here the choice is C. Thanks.